The next problem we're going to solve together is a motor start-stop with interlock. It says a motor M1 is to start only if start 1, which is normally open momentary switch, is pressed. M1 has to stay running when start 1 is released. Only after M1 starts, may the second motor M2 start by pressing start 2, which is another normally open momentary switch. Once it's started, it will stay running even if M1 shuts down. M1 is to stop running after M2 starts. And finally, anytime the stop, which is a normally closed momentary switch, is pressed, both motors M1 and M2 has to stop. Now, in order to build our ladder solution, we are going to follow the approach that we introduced earlier, which is converting this English requirement problem into binary. By doing this, we are going to highlight all of the terms that refer to the inputs and output states and translate them into binary. Remember, any term that goes as start or on or energize will translate as logic 1. Any term that goes like stop or shut down or turn off will translate as logic 0. Let's get started. A motor M1 is to start only if start 1 is pressed. This translates to M1 is to change to 1 only after start 1, which is 0, changes to 1. M1 is to stay running when start 1 is released. This translates to M1 has to stay 1 when start 1 goes back to 0, and this achieved by latching. Only after M1 has started may M2 start by pressing start 2, which is a normally open switch. This translates to only after M1 goes to 1 may M2 goes to 1 when start 2 goes to 1 or changes to 1. Once M2 starts, it will stay running even if M1 shuts down. And this translates to once it is 1, talking about M2, it will stay 1 even if M1 goes to 0. This is another requirement that's achieved by latching. M1 is to stop running after M2 starts. This translates as M1 is to go to 0 after M1 goes to 1. Finally, anytime the stop, which is normally closed momentary switch, is pressed, both motors will stop. This translates to anytime the stop, which is normally 1, changes to 0, M1 and M2 will go to 0. This is the translation from English to binary. Right now we are going to rely on this translation in order to start building the solution for this problem. As you notice from this problem, it involves 3 inputs, start 1, start 2, and the stop, and 2 outputs, motor 1 and motor 2. As there are no requirements for timing or counting or locking, for example, we can expect our solution to consist of 2 rungs controlling both motors M1 and M2 for each one of them. So let's get started by building the solution for the first rung controlling M1. Before we start, I like to have the cheat sheet for the main instructions we are going to use for the XIC and XIO. The first requirement is the following. M1 is to change to 1 if start 1 changes to 1. As this is the first requirement, I'm going to go ahead and start building the ladder rung for this solution. As you recall, each rung consists of 2 sections, an output section and an input section. As this solution for this requirement is controlling M1, it means we need to add an instruction among the output section that refers to M1. The only instruction that we have covered so far is an OTE, and this concludes the first part of this requirement, choosing OTE for M1. Now, we need to go back to the input section. As you recall earlier, we said the input section could be divided into 2 parts, an on section and an off section. Right now, we need to start with the first requirement. The input is start 1. The input that's controlling M1 is start 1. It means we need to add an instruction that refers to start 1 among the on conditions. The question is XIC or XIO. In order to determine this, we need to rely on our binary version of this requirement, always starting from the input. Get used to this. It says when start 1 changes to 1, the output, which is M1, changes to 1. So 1-to-1 relationship, this is achieved using an XIC instruction. When start 1 goes to 1, the output M1 goes to 1. That's the first requirement. Now 100% satisfied. The second requirement is the following. M1 has to stay 1 after start 1 goes to 0. Remember, start 1 is a momentary switch, so eventually after you press it you will let go. So this instruction over here will go back to false. Now if the requirement, like in this case, requires that the M1 stays on, it means from our input side we need to maintain an alternative path across, or that's going to bypass start 1 after start 1 has been released. This is referred to as latching, and the only instruction that we are always going to use for latching is an XIC instruction that refers to M1, which is simply the output. In other video I'm going to talk about the concept of scan sequence, and this will shed the light more on this idea or this concept. The third requirement, anytime the stop, which is normally 1, changes to 0, M1 goes to 0. As you look at this requirement, what is the input? Is the stop, and the job of this input is to turn off M1. So it makes sense to add an instruction that refers to stop among the off condition. The question is XIC or XIO. One more time, we're going to rely on the binary version of the solution, always starting from the input. When stop changes to 0, M1 changes to 0. One more time, this is a behavior that's satisfied using an XIC instruction. So XIC instruction has to be used over here. The final requirement, M1 is to go to 0 after M2 goes to 1. Now please look over here. Even though M2, we have not yet built the solution for M2, we can still integrate into this requirement for M1. Now what's the output that we are controlling? M1. Using what? M2. Even though M2 is an actual output, however, it can act, like in this case, as an input that's targeting M1. The question is, does M2 belong to the on section or the off section? It says over here M1 is to go to 0 when M2 goes to 1. It means M2 is going to cause M1 to go to 0. In other words, it acts as a stop. So it makes sense to add an instruction that refers to M2 in the off section. The question is going to be in series with the stop or in parallel to it? And the answer to this, you need to ask yourself, how do you want, or when do you want M2 to stop M1? Is it once you press stop, or either or? Either when stop is pressed or when M2 goes to 1 changes to 0. The answer is either or. Anytime you hit the stop or M2 changes to 1, same result, M1 goes to 0. And to do this, the instruction has to be in series with the stop, so that anytime the change happens to any one of these instructions, it will cause a false instruction. This will break the rung and M1 will turn to 0. Now the question is XIC or XIO. One more time, binary version, starting from the input or what's acting as an input. M2 going to 1 will cause M1 to go to 0. As you can see, it's an inverse relationship. M2 going to 1 cause M1 to go to 0, inverse relationship, and this is achieved using an XIO instruction. And this is the solution for M1 output. As you can see over here, we are going to follow the same approach to build the second rung that's going to control M2. As usual, let's display the basic instructions for XIC and XIO in front of us. The first requirement for M2, it says only after M1 goes to 1 may M2 go to 1 when start 2 goes to 1. As you can see in this requirement, there are two conditions that are going to control the way M2 starts, which are M1 and start 2. So let's go ahead and start building the rung for M2. As we have done for M1, the OTE instruction is going to be used for M2, similar to M1. Right now, going to the input side, on section versus off section. As per this requirement, start 2 and M1 has to be on in order for M2 to be energized. Both these conditions are required to energize M2. That's why we need to use two instructions among the on section. Right now, are they going to be in series with each other or parallel with each other? The requirement actually tells us. It says M1 has to be 1 and start 2 has to be pressed. So both of these conditions has to be satisfied to energize M2. And the rule says if you have two or more inputs with an AND relationship to energize an output, then these instructions referring to these inputs will be in series with each other. So we need to go ahead and insert two instructions in series with each other referring to M1 and start 2. Right now we come to the question XIC or XIO. One more time, to determine this, we're going to rely on the binary version of this requirement. For M1, it says when M1 goes to 1, M2 can go to 1. That's a one-to-one relationship, so we need to use an XIC for M1. Now when it comes to start 2, the same thing. It says when start 2 changes to 1, M2 is to change to 1, so that's another XIC behavior. So right now we can say that 100% the first requirement is done. The second requirement is the latching. It says once M2 changes to 1, it will stay running even if M1 goes to 0. That's the latching, and we need to create a path that's going to bypass both M1 and start 2. Even though in the requirement it does not mention start 2, but we know since start 2 is a momentary switch, then we need to bypass it, because eventually once you press it you will let go, so the bypass instruction has to bypass it as well. The latching is always an XIC instruction that refers to an output. M2 is our output in this rung, so the latching needs to be M2 as well. The third requirement, anytime the stop, which is normally close or normally 1, changes to 0, M2 is to change to 0. As this input, which is the stop, is responsible to de-energize or to turn off M2, it means we need to add an instruction among the off condition, XIC or XIO. Look at the binary version. When stop goes to 0, M2 goes to 0. That's a 0 to 0 relationship. So an XIC will actually fulfill this. And now that's the full solution for M2. The overall solution for the full program will look something like this. Two rungs, the first rung controlling M1, the second rung controlling M2. And as you look for both of these rungs, the stop conditions has to be always true. Right now, let's go ahead and see the RS Logix version of this solution, just to make sure that our analysis is correct and in place. Right now to the right side, you can see the program that we have built, but right now on RS Logix, and to the left side, you can see the memory locations showing 0 for start 1 as normally open, the same thing for start 2. M1 and M2 initially in the off state, that's why they will be driven by logic 0, and stop reading 1 since it's a normally closed switch. And as you can see, the stop conditions has always to be true, allowing the path anytime the start 1 is pressed or start 2 along with M1, they will complete the path and M2 or M1 will start. So let's start with the first one. Anytime start 1 is pressed, it will read 1 in the PLC memory. This will change the XIC instruction to true. Even when you let go, M1 is still on, it will remain on because the alternative path provided through the latch over here. As you can see, alone M1 turning on is not enough to energize M2 because start 2 has to be pressed right now. Right now, if I press stop, the stop will go to the open, will read 0, and that's why it turned off any running motor. You let go, it goes back to close, reading 1. Let's check start 2 alone. If you press only start 2, as you can see right now, this changes to true. However, since M1 is not energized yet, M2 is not yet energized. So what we need to do in order to get M2 up and running, you need to start 1 first, start M1, you let go, and now if we press start 2, you let go, M2 is on right now, but look at what happened over here. Once M2 is true, this will cause this XIO instruction referring to M2 and the first rung to false, and this is going to cause M1 to go to the off state. Right now, if I press stop again right now, it will turn everything off. You let go, it returns back to close, reading 1, and that's the program 100% fulfilling the requirements presented. So the next topic will be timers, and let's go there. Peace.